Hello everyone, it's Mr. Wolf here, and in this video I'm going to be going over the warm-up for Tuesday, January 11th. So let's get started. So we have a tiny car and a massive truck collide, and it really doesn't matter about their masses. It doesn't even matter how fast they're going when they collide. We know because of Newton's third law that the forces between them are always going to be the same. That's Newton's third law. It's always the same. All right. The force on the truck is the exact same as the force on the car by the truck. All right. So now what we want to do is we want to mark the following statements and say, hey, are they sometimes true or always true? And the hint is in order for a problem to be always true, it needs to include all variables of the equation. So we have our two equations for change of momentum right here. So if I have less time, that means that there's more force. Yeah, that could be the case, but that's only if the change of momentum is also the same. So this is sometimes true because I don't know what my delta P is right here. When mass is constant, the more delta V, the more change in velocity means the more change in momentum. Absolutely. Notice I've talked about all my variables and it's accurate, right? Mass is the same. One variable goes up on one side of the equation. The other variable has to go up on the other. All right. So that's always going to be true. So for C, when delta V is constant, more force means more change in momentum. So notice these things could be true. Like it sometimes could be true, but it's not a really good statement because I'm talking about two different equations at once. And notice that I don't know what my mass is here and I don't know what my time is here. So I don't know for sure if that's the case here. All right. For the next problem, when mass is constant, more change in momentum means more F. And again, I'm talking about two different equations. I'm going from like one equation to the other in my statement. And all right, I'm missing some variables. I don't have time. I don't have change in momentum here. I don't have change in velocity here. So that's just going to be sometimes true. It wouldn't be a good statement if this was an explanation. For the last one, all right, if delta P is constant, then more time means less force. Absolutely, right? I'm talking about every single variable in my equation, and that is accurate. You hold one side of the equation the same. One variable goes up, the other one has to change in the opposite way in order for everything to stay the same. All right, for the first problem, the correct answer is that they experience the same force. Using the equation equals F equals ma, why then would the car have more damage? And we could associate damage with acceleration. So if we have the same force, right, between the car and the truck, but the car absolutely has less mass. So if the car has less mass, then that means that in order for it to still have the same force, it has to experience a way larger acceleration. So I could just kind of draw it out visually, all right? A lot of times, like for me, that makes sense. And then once I draw it out, I just write it in a nice statement. Although they experience the same force, the car has less mass, so it experiences more acceleration and is damaged more.